If we look at a carbon-12 atom, carbon-12 atom is going to contain 6 neutrons and 6 protons. What we've done is we're going to say one atom of carbon-12 is 12 AMUs, which is atomic mass units exactly. Now, by definition, 1 AMU is equal to 1.66054 times 10 to the negative 24th grams. You don't need to know that conversion. But the importance of that, it relates then to 1 mole of carbon-12 atoms is going to equal 12.00 grams exactly. All right, but that's only if we have just one isotope, the carbon-12 isotope. But we have carbon-13 in nature as well. So when we look at carbon by itself, just in nature, it could be carbon-12, it could be carbon-13. All right, because most elements occur in nature as a mixture of isotopes, we're going to look at this average. The way we calculate the average, the atomic mass is going to be equal to the sum of the fractional abundance of the isotope times the mass of that particular isotope. When we look at the periodic table and when we look at those masses, remember the mass is under the atomic symbol typically on the periodic table. Those masses are not whole numbers because of those isotopes. So if you look at the molar mass of carbon on a periodic table, it's not 12.00 grams per mole exactly. It's 12.01. Why is it 12.01? Well, because some of the carbon in nature exists as carbon-13. So we've got to use that average atomic mass. All right, so let's look at formulas and see how these formulas are going to help us determine number of atoms, mass of atoms, moles of atoms, moles of molecules, a wide variety of things. So if I look at one molecule of H2SO4, sulfuric acid, and I pull up a picture here where atoms of hydrogen are white, atoms of sulfur are yellow, atoms of oxygen are red. Based upon that H2SO4 formula, how many atoms of hydrogen do I have in one molecule of H2SO4? Well, I would have 2 hydrogen atoms, right? There's 2 white atoms represented in the picture. Also the subscript, the H2 subscript, that 2 means there's 2 hydrogen atoms. How many sulfur do I have? Well, I have 1 sulfur atom. How many oxygens do I have? I have 4 oxygen atoms. Okay, so in one molecule of H2SO4, I have 2 hydrogens, 1 sulfur, 4 oxygen atoms. What happens when I switch to a mole, though? Well, now when I talk about a mole of H2SO4 instead of just a molecule, and you notice my shorthand notation, MOL, we'll use that to represent moles instead of spelling it out all the time as MOLE. It's not much of a shortcut, but it's what we do. So if I look at this, if I want to know the number of moles of hydrogen atoms, and the number of moles of sulfur atoms, and the number of moles of oxygen atoms, I can set up this relationship, where if I start with 1 mole of H2SO4, I want to cancel out moles of H2SO4, so I put those in the bottom in the next step. And I want to convert to moles of hydrogen atoms, so I put moles of hydrogen atoms on the top. And from that formula, I can get for every 1 mole of H2SO4, there will be 2 moles of hydrogen atoms. Now I know this seems kind of silly because you're probably going, well, duh, it's in the formula. We saw that with the molecules. It's still important to make that connection and see this relationship, because these multimole conversions are going to be very important later on, and you need to start recognizing those now. So 1 mole of H2SO4 contains 2 mole of hydrogen atoms. Using that quick math there, number of moles of sulfur atoms, we have 1 mole of sulfur atoms, and we have 4 moles of oxygen atoms. Okay, so formula weight in molar mass. Well, formula weight we typically use when we're talking about a molecule. When we're talking about formula weight, units are going to be AMUs, which are atomic mass units. So let's look at calculating a formula weight from a formula. Let's go back to the H2SO4. In order to calculate that formula weight, we'd start with 1 molecule of H2SO4, and 1 molecule of H2SO4 would contain 2 atoms of hydrogen. 1 atom of hydrogen then would weigh 1.008 AMUs. Where do we get that number from? Well, that number is from the periodic table. That's the mass under the atomic symbol. Okay, because we're talking about an atom of hydrogen, 1 atom of hydrogen, the units on it are AMUs. So we'd end up with 2.016 AMUs. We could do that for the sulfur. We'd end up with 32.07 AMUs. We could do that for the oxygen, and we'd end up with 64.00 AMUs. So we've calculated the atomic mass for each part of the formula for the hydrogen, the sulfur, the oxygen. We want it for the entire thing, so all we need to do is add them all together, and we get the 98.09 AMUs. So the formula weight for H2SO4 would be 98.09 AMUs. All right, so just a reminder, when you're looking at the periodic table, don't forget the number underneath this symbol is the atomic mass of that element. If we're talking about a single atom, then the units on it would be AMUs. If we're talking about a mole of that element, units would be grams.